Hello, good afternoon, everyone. Thank you for joining us today. We'll give you all one more minute to let the room fill up, and then we'll get started with today's exciting webinar. So thanks so much. Just stand by. Just stand by. We'll give it another 1 minute until we'll get started at 1:02. All right, well, welcome everyone. Thank you for joining us today. We're very excited for today's topic, understanding your utility bills focused on electricity. This is, as you know, this is part of our Energy Awareness Month webinar series where we have a variety of different topics. This will be one of 3 that we have coming up about understanding all of your bills. So we're focused on electricity here, and there'll be future ones on natural gas and water. As a reminder, and if you've been with us before, you've heard this announcement before, but the Zoom call is being recorded, and we intend to post it on our website and share it with all of you who, all of those of you who may have signed up but aren't able to make it with us live. You can go back and watch the recording. So just be aware of that, and know going in that you're presumed to consent to the recording and use of your voice or image. Next slide. So as I said, we are very excited to have you here. I guess I should introduce myself. My name is Eli Levine. I lead the Better Plants program. Today is a very exciting day for the Better Plants program as we've released our annual report detailing how our over 250 partners have saved over $9 billion in cumulative energy savings and 1.9 quadrillion BTU, which is the equivalent of all of the electricity that the state of Wisconsin uses for a full year. So I encourage you to go to the DOE website, to the Better Plants website, to read more of the report, and to, if you're a Better Plants partner, to highlight your participation in the program, share the report. Let's really get the word out about all of our amazing partner accomplishments. But why we're here today, Energy Awareness Month, a series of webinars. Thank you for joining us. Sign up at that link at the bottom, Yes Events, Energy Awareness, if you're liking these webinars and want to keep attending them for the rest of the month. Next slide. This is the schedule. We are halfway through by participating today. So we have one on understanding your electricity bills with 3 more to come after this. Just a quick note, as we all suffer from, or many of us suffer from Zoom fatigue or being stuck at home. Please, your feedback is well appreciated. Let us know if you like these webinars, if you'd like for us to continue to do these webinars, if there's different types of webinars you'd like for us to have, or anything else that we can do to better partner with you and support all of us towards our goals of industrial decarbonization and tackling the climate challenges we face. So, as you know, hopefully, if you've been here, please use the chat for all of your questions. We will answer them at the end, and as they are pertinent, as our presenter is talking, we may stop and interrupt him to answer some of the questions in real time. So we want to see a robust discussion and ample partner participation. So ask away. And if you want to learn more, here is our website where you can engage and find all of the documents, including the how to understand your utility bills for electricity on the website. Next slide. So it's with my great honor to introduce our presenter today. Chris Price is one of our really standout technical account managers based at Oak Ridge National Lab for the Better Plants program. Chris received his bachelor degree from Johns Hopkins University and his PhD from Texas A&M in mechanical engineering with a focus on advanced control systems. Chris does a number of things for Oak Ridge National Lab, including authoring documents like the one he's presenting about today and presented about earlier this week on the updating the baseline energy intensity and tracking guidance document. Chris also works with a dozen Better Plants partners on everything from helping them set their ambitious goals to understanding their energy use to tracking their performance and ultimately implementing their sustainability strategies. So very excited to have Chris with us here today, and also excited, honestly, to turn it over to him and mute myself and just listen to the presentation. So Chris, thank you so much for your work in presenting this document and being with us here today to present everything to the group.
All right, thank you, Eli. Let's see if I can get to go to the next slide. There we go. So as Eli said, this presentation is going to be on your electricity bills, how understanding them can help you identify cost-saving measures and energy-saving measures, really just from using your bills to track your energy consumption. This pairs pretty well with the webinar that we did on Tuesday on energy baselining and tracking. A lot of the information that you would use to make your energy baseline is going to come directly from your electricity bills, or for the upcoming webinars on natural gas, you would also use those as well. But before we get into that document, I just want to give you a brief overview of the Better Buildings, Better Plants program. Many of you are probably already partners, but for those of you that aren't, I just want to show you how this fits in with what we do as a program. So Better Buildings, Better Plants, it's a public-private partnership between the Department of Energy and US-based manufacturers. Our main goal is to help all of our manufacturing partners be more competitive, to be more profitable, and save resources. The primary way we've done that in the past is by focusing on energy efficiency measures and tracking energy intensity over time. And recently we've been adding in different missions, like trying to reduce water usage, reduce waste production, and we're even starting to move into the carbon accounting space. Now, the way that we support manufacturers in reaching these kinds of goals is through various technical support and knowledge here. So there are four main prongs that we provide support in. The first is going to be our no-cost software tools and guidance documents. Right now we have over 60 calculators, a very cool program called Measure that includes a lot of those already. We have our diagnostic equipment loan program, our financial navigator to help you implement projects, and then a whole series of guidance documents, one of which we're talking about on this webinar today. The other component of this is going to be our training programs. We have our implant trainings where we come to your facilities. We provide your staff and your workers the technical background for how different processes work, and then do energy audits and assess projects in your facilities. With COVID, we've switched this over to a virtual training model. All of those that we've done so far are online. You can go back and watch those trainings whenever you want to. They're hosted on our Dropbox. They're a great resource for identifying projects and learning about your systems. And we also have an ever-growing catalog of webinars and other presentations on energy efficiency, including this one, which will get loaded later this week. The third part of it is recognition. We know that working on your energy efficiency is a difficult job, and we want to recognize partners for their efforts. So far, we've had 59 partners reach their Better Plants goals. They obviously receive recognition from the Department of Energy, but along the way, there are opportunities for Better Project Awards, Better Practice Awards. We also have our online media, social media presence, where we can do some work with you to advertise the projects that you're working on. And we also have our Solution Center, which has over 350 individual solutions and case studies that you can go back and review and see what other partners are doing. The last part of this, Eli mentioned that I work here at Oak Ridge National Laboratory in Tennessee. The Department of Energy operates a lot of other national labs across the country. One of the benefits of working with the Better Plants program is you get access to all of the research and analysis that's being done on advanced manufacturing right now. So if you want to see what's coming next for manufacturing, we're here. We're a Department of Energy. It's a public use facility. So you're able to come see what we're working on and maybe implement in the program. The other part of this is our field validation program. We are working with partners to identify new technologies and help reduce some of the risk of implementing new energy efficiency technologies. So those are our four main categories for how we support our partners. So what this looks like is right now, Better Plants has over 250 partners across all 50 states and territories in the United States. So we have companies, these are just a selection of a few of them. You'll see that we have industries from brewing to pharmaceuticals, to cosmetics, to automotive manufacturing, and even some local governments and wastewater treatment facilities. This is really just to show all of the networking opportunities that are available to you through Better Plants. You're not only able to talk to direct competitors and see what they're doing and try and be more competitive that way, but you're able to see what other industries are doing to save energy and maybe implement some of their best practices, or there may be a technology that they're using that you didn't that you weren't aware of. So you're able to leverage all of this knowledge of having all of these different partners to help you save energy. So Better Plants as a whole, hopefully you can now see how this series of guidance documents and webinars fits into what we're trying to do here. So the webinar today is just one in a series of guidance documents that were released this month. This first one is on electricity billing. Next week is going to be the webinar on the natural gas billing document, and then the week after that would be the one on water billing. These are really meant to help you analyze your bills and then save cost and hopefully identify energy saving opportunities. The way you would use this guide and the way that we tried to put this together is really to give you a thorough understanding of how electricity is generated, why you are billed the way you are, and then to help you identify ways to avoid those costs and save energy. So if your bills were simple, wouldn't need to have a guidance document. So the reason we put this together is that electricity bills are often very hard to decipher. Some bills can be very long and detailed. They'll have a separate line item for every charge that appears on your bill. I have seen bills where literally only the total is listed, and you have to really dig into them to figure out that's what my kilowatt hour consumption was. That was what my demand was. So because everyone has a different utility provider, everyone's bills are different, it can be somewhat complicated to figure out how to dig into those bills and use them to your advantage. In addition to that, some charges can appear every single month, others don't. So why would a charge show up one month and not another? And really what we're trying to do with this document is to help you understand all of those reasons. So why your utility charges those different fees and then use them to save energy and cost. So the guide is going to cover, and this webinar is going to cover 4 basic things about the utility bills, which will lead to an understanding of the electricity bills. And that's the energy generation component, the rate structure component, so your actual contract for your energy, usage trends, how you can use your energy trends to avoid certain costs in your bills, and then ways to identify efficiency opportunities. So stepping right into it, first part of this is going to be the energy generation side. Now, electricity is going to come from many different sources. For most states, most locations across the country, it's going to primarily be a mix of coal power, nuclear power, and then gas and fuel-powered turbines. You may, depending on where you are, like here in Tennessee with the TVA, there is an abundance of hydropower. There have been a lot of investments in wind and solar. So your particular mix of energy and electricity sources can be different depending where you are at. Now, the cost of generating electricity from each one of these sources changes all the time. It can change over the course of a year, and it can change from day to day depending on the cost of fuel. Your utility is going to take this generation mix and it's going to manage which plants are operating and how much energy they're generating to try and balance how much they're making with how much needs to be used. They do this in two primary ways. I've divided these sources into baseload plants and then peaker plants. So baseload plants are generators that normally produce a fairly constant amount of energy. They're usually very slow to respond to a signal to produce more energy. So they're really good for just a solid amount of electricity that is being provided. The peaker plants are ones that can respond much more quickly. They can turn on an extra generator. They can have more turbines, more wind turbines operating to produce more energy. The costs are also different between the peaker plants and the coal-powered, nuclear-powered, the baseload plants. So the utility is going to look at this mix of energy. They're going to say, here's what we need for our baseload. Here's what we need to fill in the gaps. Here's the relative cost of each one of these, and then they're going to deploy the energy as they need it. So in general, things like wind and solar, they'll be the cheapest just because they don't have any fuel input. They're renewable energy sources. Coal, nuclear power, gas, those tend to be a little bit more expensive. So the utility is going to balance all of that. So when that energy is generated, it is distributed to your facilities through the grid. So the grid, it's a series of connections, a lot of substations, a lot of transformers. It gets the energy from where it was produced all the way to your manufacturing plant. And it's important, what's important here is because we don't have a lot of storage on the grid right now, and that could change in the future, when that energy is generated, it needs to be consumed pretty much instantaneously, which is why you have that balancing act with the baseload and the peaker plants. So that's just an overview of how you get the electricity. The next question on the generation side is what kind of market are you in? There are two main kinds of markets here. There is a regulated electricity market and a deregulated electricity markets. Regulated markets, your utility is going to control and operate everything from the generator all the way through to your meter at your physical plant. So there is a lot of stability involved in a regulated market. They're usually regulated by state and federal agencies. Pricing structures are pretty stable, and you can make a lot of plans and a lot of plans for the future based off of that energy price because it's not going to change by that much. In contrast, a deregulated electricity market is one where the energy generators and the energy distributors can be completely separate. So you could purchase electricity from one generator who delivers it to the grid, then another entity is going to be in charge of getting that power to your plant. The main goals of deregulation are really, one, to lower the cost of energy through competition. If you can buy that electricity from multiple sources, it should drive down the cost of that electricity. The second goal is really to promote green energy. If there are less barriers to putting green energy on the grid, if anyone can get a permit to start generating energy and put it on the grid, the idea is that you can adopt renewable energy, green energy more quickly. The downside of a deregulated market is that it can be a lot more complicated than a regulated market. You have more choices, you have a lot more management that you need to do. And so you might have multiple bills. You could get a bill from the generator, you could get a separate bill from the distributor. Depending on where you are, you could even have like a last mile distributor to get that energy to your actual plant. So you may get, instead of one bill, you could have three. So you need to be, you generally have to have a lot more management of your energy consumption in a deregulated market. So right now, there are currently 15 states and Washington, D.C. that are deregulated markets. So depending on where your manufacturing plants are, you may have more options for purchasing electricity than you thought. One caveat is if you are in a city that has a cooperative, usually deregulated markets exempt local utilities from the deregulated market. So you could be, for example, in Texas, but you may be in the San Antonio or Austin co-op district, and you would be outside of the deregulation there. So depending on where you are, you may have more options. So with the generation and the market side, we're going to start digging into the actual bills. And if you look at an example bill here, there's going to be 7 key components that are important to keep track of. The first is going to be the meter number. Some bills will only have 1 meter on them. Some companies, if you have multiple meters, will put it all on the same bill. So when you're looking at the bill itself, it's important to figure out how many meters do you have and what those meters correspond to. Is it a particular process? Is it a particular building? So being aware of how many meters you have and which meter you're looking at on the bill is important. The second thing is going to be the actual meter readings. These are how much energy did you consume? What was your demand? That's what you would track over time. The third thing is going to be your power factor. I'll talk more about what this is on another slide, but having a low power factor is going to be something that could penalize you, and you may not even know it. The fourth thing, fixed charges. These are things that appear every month, and they're not related to your energy consumption. So something like a customer fee, a metering fee, they are on your bill, but they're not energy related. Consumption charges, these are related to how much energy you use, and demand charges is related to the rate at which you use that energy. So you could have different blocks of charges. They could be mixed up, they could be separated out, but understanding which charges are consumption-based, which are demand-based is very important. Then the last part of this is going to be taxes, fees, and penalties. The goal would be if you know what the penalties are, hopefully you can start avoiding them in the future. So digging in here, first thing we're going to talk about is consumption. So consumption is the total amount of electricity that your facility uses to make product. It's going to be measured in kilowatt hours. It's a combination unit, a compound unit. So it is equivalent to 1 kilowatt of power sustained for 1 hour. That compound unit becomes important when we talk about demand. It can appear on your bills with various different names. It can be called an energy charge, an energy cost, a delivered energy charge. There are many names for this, but it would be related to the kilowatt hour consumption that appears on your bill. And you'll figure that out in the bill or your contract by looking for things that are billed on a $ per kilowatt hour basis. Now, your utility will come out and read your consumption every single month. They'll come to your meter, they'll look at it. There's some examples of different meters on here. So you will have that monthly meter data, but if you know where your meters are and you know how to read that meter, you can go out and read your meter every week, every day, every other week. You can start to gather more information with more granularity than what you get just from the bills. And you can do it on a regular basis in a way that your utility may or may not do. So moving on to demand charges, we talked about how much energy you use in kilowatt hours. Industrial facilities and a lot of large commercial facilities are also going to be charged for their electrical demand. And demand measures the rate at which you consume electricity. So a facility that uses X amount of power, but it's spread out over the day, the utility doesn't have to build as much infrastructure. They don't have to put in, forgive me, bigger electrical pipes for a company that uses X kilowatts, but in a very short amount of time. So the way your utility is going to calculate demand is there'll be a separate meter that is going to calculate your average energy consumption over a given window. Normally that's 15 minutes, although it can be 20 minutes or 30 minutes. It just depends on what kind of metering you're your utility does. So for example, you could watch your consumption meter, time it over a 15-minute window. If it goes up by 25 kilowatt hours in 15 minutes, divide the kilowatt hours by minutes, change minutes to hours. 25 kilowatt hours in 15 minutes is 100 kilowatts of demand. So this is essentially what a demand meter is doing. It's sitting there, it is constantly resetting and counting every window, how much energy you use, and then averaging that. So more demand, like I said, means more infrastructure that the utility has to build and maintain to get you your power when you want it, which is why the utility charges you more if you have more demand. Like consumption, demand appears on your bill with several different names. It can show up as demand charge, demand cost, transmission and delivery charge. It can have a lot of different names, but it's going to be a $1 per kilowatt type charge. Now, I told you how you would figure out your instantaneous demand, but which window does the utility use to calculate your demand? Now, your demand will naturally vary over the course of the day, and what your utility is specifically looking at is your peak demand. So this chart shows you several different days. It shows you a baseload demand and average demand. Both of those are nice to know, but what the utility is specifically looking for is over the course of a month, what is the one 15-minute window that had the highest kilowatt demand? And then that peak is going to set your demand charge for the entire month. So really what that points to is that one spike in demand, one bad 15-minute window, not only sets your charges for the entire month, it can actually set your charges for the next year. So managing when you use your energy is going to be really important to saving cost. Now, the utility is going to be measuring that 15-minute peak. That value over the course of the month, that is your actual demand. That's what the utility saw over the billing period. What your charges are based off of is actually billed demand, which may or may not be equal to that actual demand. Billed demand it's an adjustment to your actual demand that is established by different clauses in your electricity contract, your rate structure. An important note here is that billed demand, it's never going to be less than actual demand. It's always going to be greater than or equal to actual demand. So the game here is that you want to make sure that your billed demand is as close to actual demand as possible so that you avoid those extra charges. So what are a couple of clauses that would increase billed demand? One is going to be a ratchet clause. These are stipulations in a contract that generally fall into something like 80% of the maximum observed demand over the last 12 months. So if you look at this example, there is a whole year's worth of data. If your demand was constant every single month, the ratchet wouldn't affect you at all. But let's look at July of 2020. It's that top bar there. You can see that the ratchet demand, 80% of that peak, goes up. And then for the next 12 months, the minimum demand that the utility will charge you for is 80% of that peak. So when you get your bills, your billed demand, it's not going to be what your actual demand is. It will be at that ratchet demand. So the penalty for a ratchet clause is the difference between that ratcheted demand and your actual demand. And as you can see, it builds up over the course of the year and it can cost you extra. Something similar to this is going to be a coincident peak clause. So your facility has its peak demand, but a coincident peak is going to be what is your facility's demand when the grid hits its peak. So in this example, the facility hit its peak around 2 o'clock in the afternoon. The grid hit its peak around 7 p.m. In this case, because the facility was shut down, not a problem. Where you start to get extra charges is if your facility hits its peak at the same time as the grid, that's when you can get those extra charges. Also related to this, some companies will charge you for coincident peak demand. What that is during summer months, a utility would call 4 peak events. And your facility's average demand at each one of those peak times is averaged and then used to set your 4CP demand charges for the next calendar year. So you could hit a peak theoretically in July of 2020 and then not see the result of that peak until January of 2021 and then pay for it all the way through to 2022. So making sure that you avoid those peaks is pretty important to minimizing your bill demand. So how do you manage demand? The game here is going to be managing your facility's load profile. So you would change when you consume energy to avoid hitting that peak. There are 2 main strategies to do this. The first of which is going to be load shedding. You simply tell people to unplug their computers, you turn off lights, you set back HVAC units, maybe you turn off a piece of equipment. You're really trying to minimize how much energy you're using in a given window to avoid that peak. The other strategy is load shifting. So you could take a process offline. If you have the ability to reschedule and do that production later in the day, you can avoid that peak consumption and move it to a time when there is no peak or the electricity is cheaper. A lot of utilities will offer demand response programs to incentivize companies to do these kinds of strategies. And a lot of times those programs can provide you incentives. They can give you a little bit of extra money at the end of the year, depending on how you respond to those events. Better Plants is going to be releasing a document in the next couple of months on demand response. So if you want to know more about that, stay tuned. We'll have guidance on that pretty soon here. The next demand related issue is going to be power factor. What I'm hoping to do with these slides is give you a general idea of what power factor is and why you're penalized for it. Don't feel like you have to understand the math behind it. I'm just trying to give you the flavor of why a utility would charge you for a low power factor. So the way that AC power interacts with the equipment in your facility is going to affect how much power the facility has to deliver to your plant. How much extra power the facility has to deliver is captured by the power factor. Most utilities will penalize you for having a low power factor because it means they have to provide extra energy to your plant versus if you had a higher power factor. Now, power factor is going to be inherent to all AC circuits, but it can be managed. And with the next couple of slides, hopefully you'll see why here. So if you look at a single phase AC signal here, you have a time varying voltage with a magnitude and a frequency of 60 Hertz, a time varying current with a magnitude and a frequency, but the current can be out of phase with that voltage. And depending on the equipment in your plant, that phase difference can be pretty small or it can be bigger. What does that phase difference mean? Well, if you look at instantaneous power, if you multiply voltage by current, do some of the math, you end up with an expression for instantaneous power that has 2 parts. The first is going to be real power measured in kilowatts. This is actual energy that does work in your plant. It lifts a pallet, it turns a motor, it heats a building. This is energy that is being used for work. The other part of this is reactive power, which is measured in kilovolt amperes reactive. This is necessary to operate your equipment, but it does no actual work. So, for example, in a motor, for the motor to operate, there need to be magnetic fields set up in the motor. Those magnetic fields don't do work, but they allow the motor to spin. So you need both of these components. The issue is that the utility doesn't just supply either real power or reactive power. they actually supply apparent power to your facility. And how much apparent power they supply is related to that power factor. The relationship is governed by the power factor triangle. You've probably seen this before. Real power is on the bottom, reactive power is over on the right. Apparent power, the thing that the utility is delivering to your plant, is the hypotenuse of this triangle. The angle of the triangle is related to that phase difference between voltage and current. So what you'll notice is that the apparent power is the same as the real power or more. So the more phase lag that you have, the lower your power factor. Essentially, the more apparent power the utility has to supply your plant. So for a given amount of real work, the lower your power factor is, the more apparent power the utility has to supply. And that's why you're penalized for a low power factor. Now, power factor is usually listed on your bills directly. You can see it, it'll be a number you can record over time. Power factor penalties are very rarely clearly listed on your bills. So it can be difficult to know if you're even penalized for it. And in most cases, you probably are. How you're penalized for low power factor depends on how you're billed for that demand. If you are billed based on real power, so you'll know this if your demand charges are calculated by kilowatts. Your utility will have a minimum required power factor, and that's usually 0.9 to 0.95, somewhere in that range. You can calculate your adjusted demand, power factor adjusted demand, by multiplying your real demand by the ratio of the required power factor to your actual power factor. And the demand penalty for having a low power factor is just your cost of demand multiplied by that difference between the adjusted and real demand. Important here is that you are only penalized for a power factor that's less than the required power factor. So if you were correcting it, you would only correct it up to that minimum required. You would never try and get it up to 1. If you're billed on apparent power, so how much energy the utility is having to actually supply your plant, you are inherently penalized for any power factor less than 1. And that's because from that power factor triangle, if you have any reactive power in that power factor triangle, the apparent power is greater than the real power. The penalty here is just the difference between that billed demand in kVA and your real demand in kilowatts. You can just subtract one from the other. The units work out just fine. If you don't know your real demand, you can just take that billed demand in kilovolt amperes, multiply it by 1 minus your power factor and your cost of demand. So depending on how you're billed for demand, that penalty can show up in a different way. So how much does a low power factor cost you? Run through a quick example here. Consider a facility that has an average power factor of 0.85. The demand cost is around $8 a kilowatt. There is no ratchet clause. If there was a ratchet clause, the cost would be greater because your billed demand could be adjusted, that ratchet demand could be adjusted upward by the power factor adjustment. The utility requires a minimum power factor of 0.95, and the average billed demand is 850 kilowatts. In this example, they're billed on kilowatts. Figuring out what the real demand is, you would use that first formula I showed you, except flip it because we're going to find real demand, not the adjusted demand. When you work through it, what you'll see here is that every month, the bill is adjusted upwards by about 90 kilowatts because the power factor is below the requirement. If you multiply that 90 kilowatts by the $8 a kilowatt, over the course of a year, you're talking about $8,500 or more in penalties because the power factor is too low. This just gets worse if your power factor is 0.8 or 0.75. And you may not know that that penalty is there because it's not a separate line item on your bill. So how do you fix a low power factor? Well, nearly all facilities have a low power factor because they have large motors in their facility. Motors are just essentially large coils of wire, which is the definition of an inductor. And inductors cause the current to lag voltage. So the way you would correct this is by installing capacitor banks on site to offset the inductive loads in your plant. There are two kinds of capacitors. There is static capacitance, which is cheaper, and dynamic capacitance, which is more expensive. The static capacitance is going to provide a constant amount of capacitance. The dynamic systems have electronics in them that let them vary the amount of capacitance that your plant has to fine tune what that adjustment is. So you would fix a base load amount of phase difference. You would fix really a base load amount of power factor with that static capacitance, and then fix the remaining with the dynamic. And that way you minimize the cost. And typically, if you look at the IAC, the Industrial Assessment Center database, paybacks on fixing power factor are usually around a year to a year and a half. They're almost entirely under 2 years. Other charges on your bills can show up in addition to those direct consumption and direct demand charges. One of the main things that you'll see is a whole bunch of riders. And riders are going to be modifications to your rate structure. So your rate structure may say that your consumption costs 5 cents a kilowatt hour. A rider is going to adjust that up or down depending on certain parts of your contract here. Some riders are only going to apply certain months of the year. So a rider might only apply January through March, which is why some charges could appear on your bills at certain times of the year and not in other times of the year. You can usually spot a rider because they'll have a very descriptive name that tells you what the purpose of the rider is. So that's going to be something like a renewable energy development fund, nuclear decommissioning charge, energy efficiency cost recovery factor. It usually tells you what that charge is going for. Riders can be billed on your kilowatt hour consumption. They can be billed on your kilowatt demand. It just depends on what the rate structure says. So if you have a whole bunch of riders, you can go to your contract and you can see them listed out and then correlate that to your actual bills. We've covered a lot of the energy-based charges, but there's also going to be a few kinds of charges on your bills that are not related to energy. So the first of which are going to be fixed charges. These are built into your rate structure. Those are going to be things like customer fees and metering fees. They're not really avoidable. They're just part of the contract, but making sure that you have the right schedule, the right contract is important because the charge, the metering fee can be different depending on which plan you're on. Other non-energy charges that can appear can be completely avoided with a little bit of planning. So things like late payment fees, insufficient funds fees. If you work with your billing departments to make sure that you understand that your utility requires having your check in hand by the due date, or if they just need to see that the bill was postmarked by the due date, that can save you a lot of money over the course of the year, because essentially a late payment fee is just a very high interest loan for your energy. So avoiding those is pretty critical. The last one here is going to be tax related, local taxes, sales taxes. Those will be a certain percentage of your bill. An important note here is that at the state tax level, a lot of states allow manufacturing companies to claim an exemption from state sales tax if they can show that a certain percentage of the energy on a meter is related to manufacturing purposes. You would apply for that exemption by getting a predominant use study to verify that that percentage of energy for that meter is manufacturing. And some states will even let you claim 2 years of back taxes. You can get a refund for 24 months of state sales tax. It just depends on the state that you're in, if the exemption exists, and if you can claim a rebate on past sales taxes. So working with your utility to figure out if that's an option for you can save you some cost there. Now, we've gone over specific charges. The next few slides are going to talk about why those charges appear on your bills. So your utility is going to offer several different rate structures, several different contracts in a document that's called a rate schedule. So all of the ways that they let people purchase electricity are going to be part of that rate schedule. Choosing the right rate structure is critical to minimizing your overall energy costs. If you are on a service that's too small, you can have penalties for using too much energy. If you're on a service that is too big, you could get charged for not using enough energy. So making sure that you're on the right schedule is very important to avoiding unnecessary energy spending. Some example schedules that you might be on at your manufacturing facilities: exterior lighting for parking lots and outside walls. In general, most facilities will be on some sort of service designated as general service, small, medium, or large. The important thing with these is that there's going to be a criteria for a minimum amount of demand or a minimum amount of consumption to qualify for that. The types of charges that they have are all going to be different. Some may not charge demand, some may charge demand on kilowatts, some may charge demand on kilovolt amperes. So looking at the full slate of what is available to you can help you pick the right one. Now, in each one of those schedules, there could be a different pricing option. A very common one is just a uniform pricing structure. The more energy you use, your unit cost does not change. You could have a decreasing block structure. The more energy that you use, the cheaper that energy becomes. You could have an increasing block rate where the more energy you use, the more expensive that energy becomes. Utilities around the country are starting to do time of use rates, one of which is an on-peak, off-peak rate structure. So depending on the time of day that you use that energy, your energy costs could be more expensive. That's where managing your energy consumption, you could shift things to a cheaper energy time, becomes important. A new option that's starting to come out with smart meters and more computing technology is real-time pricing. So rather than having a fixed time of day where the energy costs a certain amount, real-time prices fluctuate with the market. So depending on fuel costs or weather events, energy prices could vary all over the place. So knowing which one of these you're under can help you get to a cheaper energy block sooner, or avoid hitting a higher energy block entirely, moving energy around to make sure that you're getting the cheapest rate. Those are all very important. Now, how do you calculate your actual cost of energy? When you're starting to evaluate energy efficiency projects, how would you use your bills to estimate how much you could save? And there are two main ways of doing this. The first is going to be a blended cost of electricity. This is very quick, very easy to put together, but it's only going to estimate savings from energy consumption reduction projects. So a blended cost is just your total cost of electricity over your total kilowatt hour energy consumption. That is going to roll into it things like demand charges and fixed fees. It's just that if you had a project where your energy consumption does not go down, you've just moved demand, a blended cost isn't really going to capture that. A more detailed way of capturing your cost is going to be a marginal cost, and that is going to require that you really know your rate structure inside and out. So essentially what you would do with this is you would look at your rate structure and you would say, here are all of the charges that are related to kilowatt hour consumption, and add those all together. And that is your dollar per kilowatt hour cost of energy. You would do the same thing for demand. Everything that's built on kilowatts, you would add together, and you would say, every kilowatt of demand I save, here's how much money I would save. So you can do it the quick way with the blended cost. You can dig into it with the marginal cost. So what does this look like? If you go back to that example bill I showed you earlier, There are 3 consumption-related charges. This has block energy charges. So energy charge 1 applies to the first 250,000 kilowatts. Energy charge 2 applies to every kilowatt hour above that. There's also a rider for energy efficiency. There are several demand-based charges. Those apply to the billed demand. They're all listed there. There's also a series of other penalties and fees on that bill. So looking at the cost of energy for that bill, the blended cost for that bill is just $32,000 over 420,000 kilowatt hours. The estimated cost of electricity, the blended cost, is about 8 cents a kilowatt hour. And that includes demand and all the other charges in there. For the marginal cost, because it's on a block structure, if you know that 4 months of the year, you never hit the block 2 rate. So 4 months out of the year, if you save a kilowatt hour, it would be at the block 1 cost. 8 months out of the year, it would be at the block 2 cost. You can figure out what your marginal cost of consumption is, and that is about 5 cents a kilowatt hour. You can do the same calculation for demand, which is about $5.50 per kilowatt. So if you were evaluating an energy efficiency project, you would know if we save this many kilowatt hours, here's what our savings are. It also saves on demand. Here's what our demand savings would be. Now, opportunities that you can identify from analyzing your bills. We talked about a few of them on some of the other slides. Demand management, this is the load shedding and load shifting. Can you move your energy around to avoid costs? Power factor correction, if you know your power factor and track it over time, you can figure out what the penalty is and then figure out if a power factor correction project is cost effective for you. Recreating your bills. If you know how you are billed for your energy, you can audit your utility yourself. You are able to spot billing errors. If you're on top of your bills, you're able to spot issues with metering. Water meters, natural gas meters, sometimes they can fail. Knowing that ahead of time, you can correct for those metering errors before you have to pay for them. State sales tax exemptions, just knowing if you're being charged for sales tax on a meter, even though it is production predominant, that is important to saving costs. And then avoiding late fees, that's just a management issue, making sure that you get the payment where it needs to be. The last two I want to talk more about on the remaining slides here, and those are going to be tracking your energy consumption, spotting trends and anomalies over time, and then an analysis known as production and load factor analysis. So tracking your energy usage, if you know how to read your bills and you're collecting them, you can start putting together spreadsheets to look at how you use energy over time. You could do this on your own, but DOE offers several software tools that make that process easier. You can use them to spot trends, anomalies, and look for opportunities for energy and cost savings. So the first software tool is going to be the energy footprint tool. You can use this to store information from your bills and trend it over time. You can even track other variables like production, heating demand, cooling demand, water usage. All of that can go in this document. It gives you a common place to put that information, and it has that trending capability built in. The other part of it, I touched a bit on the Energy Performance Indicator tool at the webinar on Tuesday. This is more for the regression analysis, the energy intensity analysis. So the footprint tool, you can collect that data. The Energy Performance Indicator tool would be used to baseline and then calculate your efficiency improvements over time. So together, those two pieces of software can really help you spot issues. When you're doing that analysis, an important thing to look out for, particularly with electricity bills, is the issue of billing periods. Those periods depend entirely on when your utility reads your actual meters, and that can be consistent every month, or it can vary by several days. So the process of normalizing for those varying billing periods is known as calendarization. In general, you would take the consumption on a bill, divide it by the number of days on a bill, and then allocate days to the correct month. So what does this look like? A quick example here. What you'll notice is that December, January are both kind of reasonable. Those months each have 31 days. 30 days and 33 days, those are only off by around a day or two from the build period. But then you look at February, that only has 24 days. It's already a short month, but the way the meters were read, it's cut down only to 24 days. So if you were to trend your energy consumption, January to February, there's 9 more days of energy consumption on January's bill than there are in February. So when you're looking at trends, it's important to make sure that your billing periods are consistent and the number of days doesn't vary all over the place. The other part of it is your utility could read your bills in the middle of the month. If you're tracking production and weather, those are going to be based on calendar months. So your energy consumption that goes from the middle of the month to the middle of the next month, you could have some differences just because those two periods don't align. So being aware of that is important. The last slide here is load factor and electrical factor analysis. This is using that energy data to understand how you use energy. So electrical load factor is just a ratio of monthly kilowatt hour consumption to your theoretical maximum amount of energy consumption. So if you take your billed demand and your billing hours, so the number of hours in the given month, that demand is your peak 15 minutes of energy consumption. You multiply it by the number of hours in the month. That is an estimate of how often in the month did your facility run at its absolute peak energy consumption. Unless your facility uses a constant amount of energy, it's going to be fairly low. Another version of this is looking at your production load factor. So instead of multiplying by the total billing hours, you'd multiply by your total production hours. And this is a ratio of when you were operating, how much were you operating at peak energy consumption. What this looks like, you can see your energy and demand on the left there. The right is a plot of your electrical load factor and production load factor. And electrical load factor of around 0.2 is usually a single shift production facility. There are common ranges for 2-shift and 3-shift operations. If you are a 1-shift operation, but you operate like a 2-shift operation, that can usually signal that you have equipment running outside of operating hours. It can really help you understand that you are operating equipment when you really shouldn't be. A production load factor, ideally, it would be equal to 1. When you're operating at peak capacity. But in general, a value of around 0.8 is going to be pretty good. A PLF value that is significantly higher than 1 is going to indicate that equipment is being left on outside of operating hours. And that's just a signal that you need to have better shutdown operations, better control of your energy management over time. So in that way, you can use the software tools and this load factor analysis to try and identify energy savings opportunities. So with that, that is all of the slides that I have, and I'm very happy to answer any questions that you might have. So thank you.
Wonderful. Thanks so much, Chris. That you can hear me, correct?
Yes.
Great. Well, the first question we had was from Anne, a friend of the program. How is cost recovery figured by utility?
Cost recovery, I'm assuming this is related to the riders in there. All of those are going to be set by the public utilities, either at the state or the federal level. That's something that larger manufacturers can have a say in. So if you want to be part of your electric reliability councils, you could have an effect on those cost recovery factors. But in general, that's going to be listed out in your rate structure.
Great, thanks, Chris. And I know we are approaching the 2 o'clock hour here on the East Coast. So if folks need to drop off, that's fine. But I know that you're willing to stay on for several minutes more if folks have questions. Oh, wow. And we have a number of questions coming in. So just going through, yes, Rochelle, we will post the copy and we'll share a recording of the presentation and all of that just as soon as we get it transcribed. You can put it up on the website. How do ELF and PLF relate to the baseline?
Well, baselining, that is comparing your facility to itself over time. You can use the ELF and the PLF. You could say, here's what those values were last year versus this year, and use that as a baselining metric to say, last year we were operating more like a 2-shift operation. Now we're operating more like a 1-shift operation. Our PLF is closer to 1, so we are using our peak electricity more consistently. We're doing a better job of managing our energy over the course of a month or a year. So the ELF and PLF are an extra tool in the baselining energy analysis thing. And you can use them for baselining, but they're not part of what you would use for your Better Plants baseline. Hopefully that makes sense.
Yes, thanks, Chris. And I'll comment that I've gotten a couple of notes as to how helpful this presentation was. So I very much appreciate you taking your time today. For everyone, I've linked to the report that Chris and the Oak Ridge team put together. If you want to read the actual guidance document that supports the presentation today. Another question we got, and we've got a few of them here. Sorry, is there any risk associated for a FP greater than 100%?
A power factor greater than 1? Yes, you can overcorrect. You can have more capacitance in your facility than you have inductance. That would essentially lower your power factor again. It's just in the opposite direction. So you would get penalized for that. The issue with that is that having too much capacitance has other implications for the grid that can be worse than just having a low power factor. So in general, you would never want to correct your power factor all the way to 1. You would want to have a little bit of a buffer with that dynamic capacitance. You would usually only correct it to about 0.95, 0.96, somewhere in that range. So when you're talking about that power factor, you can overcorrect. It's very rare that happens, just because manufacturing has a lot of motors, a lot of inductive loads, but it is a possibility.
Last question we've gotten so far, Chris. When using an energy management company, what analytics should be requested from them to assist in reducing energy use, such as peak times or penalties that you spoke of?
Yep. Really, the key one is going to be your 15-minute demand profile. Pretty much every facility, pretty much every utility, you can request your 15-minute demand data from them. That's not going to be on your bill. It's something that you can either request, or I know that utilities in Texas had an online portal that you could log into and see what your demand profile is. So that would be the data that you would need to know. Here's where we hit our peak demand during the last month. It was at 1:45 in the afternoon on Tuesday the 12th. You would also need to know the information about when the grid hit its peak. Usually your utility company will publish a public document that has that information in it. The grid hit its peak on this date at this time. And you can use that to put together a historical picture of, okay, we know that generally for the last 5 years, the grid hit its peak at 4 o'clock, between 4 o'clock and 6 o'clock in the afternoon, between July and September. That's the kind of information that you would need to have access to. If you are hiring an energy management company, they would probably be doing that request, the request for that information to the utility on your behalf. But if you want to start looking at this yourself, that kind of information, you can request it from your utility and start looking at it yourself, and start doing that demand management calculation and start figuring out, well, maybe we can move this process to later in the day and avoid some of those demand charges. Or like if you have a bill where your demand is particularly high, you can go back and look at that demand profile and say, what happened? Why was our demand 100 kilowatts more than normal? When did it happen? What was going on in the facility at that time that caused that to happen? Maybe you have multiple compressors and all of them kicked on at exactly the same time because a control was overridden. Those are the kinds of things that you can start doing with that kind of data. So hopefully that's helpful.
No, very much so, Chris. So I think with that, we will give you a chance to get some water, and thank you for all of your presentations. For everyone who liked everything that Chris was saying, you have his email there directly. Feel free to reach out to him, reach out to me. If you're not a part of the Better Plants program yet, please, join. You can have someone like Chris or someone like Chris at your fingertips to work with you on all of these challenges. The next webinar is actually Tuesday, October 19th at 11 a.m. And that is very similar, but it's about understanding your natural gas bills. So if you like this one and want to play it forward with natural gas, we will be reconvening at 11 a.m. Eastern time on Tuesday. So sign up at that Yes Events link below. Thank you so much, and we will see you all soon.
Yep, thank you.